Hi, my name is Dylan Stinson, and I'm a product manager for Tektronix. In this video, I'm going to demonstrate how to make a phase and group delay measurement using the TTR500 VNA. Phase and group delay are two measurements that can be used for determining if there's distortion in your device or network of devices. In this setup, I'm measuring a bandpass filter using a two-port measurement. And I've got an N-type phase-stable cable connected to an adapter that's connected to the bandpass filter on port 1. Prior to making a measurement, I performed a full two-port calibration on port 2 and port 1 of the VNA up to the dot. And in order to account for the change in adapter used in the calibration versus the measurement, I performed a port extension to compensate for the change. See how to make a full calibration and port extension in our previous videos. In VectorView PC, you can see that we're measuring the S11 trace of the device under test. To look at the forward transmission, or the S21 trace, go to Measure and S21. And I'll scale to get a better look at it. Now to look at the forward transmission, or the forward insertion phase response, let's add a trace. So go to Trace and Allocate Trace. To make this more clear, I'll change the trace layout and click Trace 2, and let's go ahead and change that to phase in degrees. And to get a better understanding of where our pass band of the filter is, let's go ahead and add a couple markers to each trace. And I'll place these on roughly the -5 dB mark, just to get an idea. So now we're looking at the pass band of the filter and the phase response from port 1 to port 2. And you can see in this phase measurement, we're bounded by +180 and -180. And so we can see that there's a relatively linear phase response, which is good and is what is one of the requirements for distortionless transmission. And I'll expand this window a little bit more. And there are a couple deviations, but you probably can't really tell in this view. To get a better view, we can go to Format, More, and Expanded Phase. So now we're looking at the phase response no longer bounded by the +180 or -180. And we're seeing quite a linear response, which is good and ensures that we're going to have a device that is distortionless, at least in the phase. And another way to look at this is if we take the derivative of the phase trace and if we take the derivative versus frequency, we can get the group delay. Group delay is the transit time through our device under test versus frequency. So to do that, go to Format and click Group Delay. Now, since this is the derivative of phase response, we're now looking for a constant value for distortionless transmission. Where phase response, we're looking for a linear or a constant slope, we're now looking for a constant value. And you can see through the passband of the filter, it's relatively flat, which is good. But there are some deviations from linearity. These deviations from linearity can be the cause for distortion through our device. And if we wanted to, we could measure the peak-to-peak deviations. And these deviations are often specified in the device under test data sheet. And in VectorView PC, to get a more analysis, you can even save and export S-parameter files to analyze with any common EDA simulation tool. So now that we've done that measurement, you can see that this filter is performing relatively well in the passband, which is what we would expect. In this video, I showed how to make a phase and group delay measurement and how easy it is using the TTR500 VNA.
Find out more at Vicom's website.